Globular cluster is a spherical collection of stars that lives inside a galactic halo above and below the galactic plane. Its name is derived from the Latin word globulus, meaning small spherical body. Our home galaxy Milky Way has more than 150 globular clusters. Our neighboring galaxy Andromeda has around 500 globular clusters, and roughly 1500 globular clusters are discovered in the M87 galaxy. The stars in these clusters are very densely packed, having more than 1000 stars per cubic parsec near the core. In comparison, stellar density in the solar neighborhood is only 0.14 stars per cubic parsec. The distance between the stars at the core is 1/3 of a light year, that is around 12.8 times closer than the Sun's nearest star, Proxima Centauri. Since these stars are densely packed, they are tightly bound together by gravity that molds the cluster into a spherical and sometimes ellipsoidal shape. Globular clusters are classified from class 1 to class 12 according to their star density. The most concentrated clusters are classified as class 1, such as Messier 75, and the least concentrated clusters are classified as class 12, such as Palomar 12. Globular clusters are like retirement homes. The stars in these clusters are primitive and fall under the category of population 2 stars. Stars that live here are old, metal poor, and less luminous than population 1 stars. These retirement homes are ideal as they are dust free and are located away from the hustle and bustle of the galactic plane. No new star formation is seen in these clusters as all the dust and gas are consumed by primordial stars from the very beginning of the universe. Stars in some globular clusters are 13.7 billion years old, which makes them almost as old as the universe itself. As these stars are born in the early stages of the universe evolution, they have higher concentration of hydrogen and helium and a lower amount of metals than the new generation of stars. This is because heavier elements such as carbon, silicon, oxygen, iron were manufactured inside stars by the process known as nucleosynthesis, which takes millions to billions of years to produce. Massive stars, when die in a supernova explosion, they eject these heavier elements into space. As time passes, concentration of metals increases in the universe and young stars get more metals in comparison to old generation stars. This is the reason the metallicity of young stars is higher than the primordial stars. As planets form in the metal-rich environments, the probability of finding a planet, especially rocky planets in the globular cluster, is very low. However, a Jovian planet is detected orbiting a binary system consisting of a pulsar and a white dwarf star in the M4 globular cluster that is located 70 to 100 light years away from our home. In globular clusters, stars are so dense that if any planet exists in the core, the night sky on that planet will be full of bright stars that will lighten the planet 20 times more than the full moon night on Earth. Globular and open clusters such as the Pleiades are great assets to astronomers in understanding the various stages of evolution of the stars. This is because all the stars in these clusters are almost the same distance from the Earth. So if a star is dim in these clusters, it is certain that it is actually dim related to its companion stars and not due to it being located far back. Similarly, if a star is bright, it is undoubtedly bright with respect to its colleagues and not due to being closer to the observer. Due to high density at the center, the merger and transfer of mass between stars are common in the globular clusters. As a result, varieties of stars are born, including blue straggler, pulsars, binary systems, etc. Blue stragglers are believed to be born from the merger of stars. After the merger, the resulting star is more massive and hotter than its neighboring stars. The hotter surface shifts its color to blue, making it look young and an outsider. As blue stragglers are massive, they slow down and shift towards the center. On the other hand, the speed of lighter stars is higher and therefore mainly found at the periphery of the clusters. Just like galaxies, there is also a possibility of an intermediate mass black hole residing in the center of these globular clusters. As stars in the globular cluster are roughly the same age and composition, they are believed to be born inside a giant molecular cloud. Globular cluster orbit the galactic center and can take forever to complete one revolution. For example, Messier 10 will take around 140 million years to complete one orbit around the galactic center. This sounds a lot, but this is nothing in comparison to Caldwell 25 globular cluster, which will take around 3 billion years to complete its orbit. I hope you find this video useful. Don't forget to like, share, comment and subscribe. Thanks for watching.